Okay, everyone, good afternoon. Thank you all for joining. This is our last webinar session for Module 4, which Dr. Magori will take us through. And after this webinar session, we'll have a period of 2 weeks until we meet again for the in-person session. The event will be from the 8th to the 10th at 4 Points by Sheraton. I'll also send an email with an updated program and more details regarding the in-person training. But additionally, the e-learning phase was also due to be activated after the second module, but due to some delays in quality check, it will be activated hopefully by end of week or early next week. So all of you will be able to start learning on ATINGI. At least the English content will be ready by Monday. And you'll have a period of up to 6 weeks to complete the e-learning. So I'll now hand over to Dr. Magori to take us through the fourth module. And I'll later just recap regarding the in-person training. To you, Dr. Magori.
Okay, thank you, Mwamini. I think I have turned on the camera so that everyone can even see me. Yeah, thank you, and I'm glad to have you again in this training session. And today we are going to look on another module, which is on wastewater treatment. So I think it is visible, and all of us, we can see the slide. Yeah, the module title is Wastewater Treatment and Disposal. And the trainer is myself, Dr. Magori Nyangi. In this module, what we shall cover is that we expect that all of you, will be able to explore key concepts such as wastewater, separation, and pre-treatment, so as to ensure contaminants are removed before further processing. And also, we expect that the learner should be able to examine or to understand the advanced treatment technologies designed to improve water quality and support reuse initiatives. So the content of the module is that we shall start with the overview. We'll look on the overview of the wastewater in Tanzania, wastewater treatment, the practices that we are having here in Tanzania,
We have lost Dr. Magori indeed. I am following up with him as we speak to understand the channel. Oh, he just left. He's probably rejoining the call. Apologies for that disruption. So Dr. Magori is back and he's connecting. He's going to be presenting shortly. Mm.
Yeah, we are going to cover the overview of wastewater in Tanzania, wastewater treatment practices, sustainable and eco-friendly practices, cost-benefit analysis, as well as the emergency responses planning in industrial aspect. So to start with, what is exactly wastewater is? This is just any water that has been used and is no longer clean or suitable for immediate reuse without treatment. This is simply because this water could have been contaminated by various contaminants. So in short, the wastewater are categorized into mainly three categories. The one is the industrial wastewater that we are going to cover. The second one is agricultural wastewater, and the third one is municipal wastewater. On the right-hand side, you can see the physical appearance of the water that we consider it to be a wastewater. So in short, in Tanzania, there is high generation of the wastewater, mostly in big cities. For example, it has been found that around 12 million of wastewater is generated daily, mainly in big cities. And this, like 60% of it, 60% of the 12 million of the wastewater that has been generated is from the big city like Dar es Salaam. The characteristic of the wastewater is that the wastewater is mainly composed up of three main aspects. The first one is physical characteristics. The second one is chemical characteristics, and the third one is biological characteristics. The compositions of the wastewater that are considered as a pollutant are the one that make a wastewater unsuitable for use in such a way that this kind of water cannot be used because before further treatment. For the case of physical characteristics, this is just the normal appearance or the features that can be sensed by various sense organs like temperature, color, turbidity, odor, and even total solids. The chemical characteristics include a range of pollutants such as the pH, the COD, and the BOD. These are considered as the organic content in water. And we do also have the nutrients like nitrogen, phosphorus. We have some inorganic like chloride, sulfate, alkalinity. And in this category, we also do have the heavy metals. And the last characteristics of the wastewater category is the biological characteristic. This is composed up of various microbial populations such as bacteria, virus, fungi, protozoa, and many other microorganisms that can contaminate wastewater. But in short, the composition of any wastewater mainly depend on the source of water. For example, for the industrial wastewater, depending on the activity that is performed, like mining industries, we expect that in mining context, such a wastewater could have been contaminated by high level of heavy metals. So the composition of any wastewater will mainly depend on the kind of the process that is taking place during the process itself. So why then should we bother to remove or to treat wastewater? Treatment is just the process of removing these various contaminants. One of the reasons as to why the wastewater should be treated is that this will help to protect the environment, but also it reduces pollutants. And another reason is just it enable various processes or the industries to comply with regulations. As we know that there are some regulations that requires any activities that is producing the wastewater should also be able to reduce such a pollutant from the wastewater so as it can be safe for discharge or disposal. But again, is that we expect through treatment, such water may also be able for reuse or recycling. So in short, we can say that it is essential that for any industry also to have the system of treating the wastewater that is being produced within the industrial processes. And so as to comply, because there are some regulations. For example, in Tanzania, we have several regulations that ensure that all industries or any activities that is producing a wastewater before it can be discharged, then they must have a ways of treating the water to make it safe. One is the Environmental Management Act of 2004. We have the water quality standards. We have the National Water Policy of 2002, which has been amended this year to 2025. We also do have a municipal wastewater management guidelines. So we have several regulations that ensure that a wastewater is treated before it can be either reused or discharged or disposed to the environment. Now, for the processes, the systems, the whole system of treating the wastewater, it comprises of the collection system. But this one, we should understand the scales at which the wastewater can be treated. These scales also ensure that the collection system that collect the wastewater from the point of production to the point where the treatment can take place. We have the centralized collection system, whereby this is mainly in big cities like Dar es Salaam, whereby we have the pipes and whatever that can take water from the point of production to the point of treatment. And in most cases, the centralized system ensure that several processes that are producing the wastewater, maybe from the households, industries, and even agricultural processes, they are all connected to the sewerage system that will direct this water to the point of treatment. But we do also have the decentralized system. These are connections in a small small towns or in rural area, whereby a point from the point of production of the wastewater to the point of treatment is not that long. But sometimes we have the on-site treatment. The on-site treatment is when the wastewater is treated at a point where they are produced. So the collection system is mainly through the centralized system, decentralized, as well as the on-site where the wastewater does not requires the connections like pipes. So in big cities, the connections, the centralized system is connected only to 20% of the potential sources of wastewater. Now you can realize that we have like 80% that may do the wastewater treatment through the on-site methods of water treatment. Here we have one of the collection network, the wastewater collection network, and this photo was taken in Iringa, where they were trying to construct the municipal wastewater collection. But here we have also another photo showing a wastewater collection using a private-owned trucks. We know that the one that is mandated for the collection of the wastewater is the like in Dar es Salaam, we have the DAWASA. The DAWASA in big cities, all big cities do have the authorities that are responsible for the wastewater and water management. So this one have also authorized some private companies to be responsible for the collection of the wastewater and to take them to the point of treatment. Now, what is the main processes after the water has been collected or has been channeled to the point of treatment? What is taking place at the treatment point? We have mainly for the treatment of the wastewater, as we have seen before, that there are various compositions of the wastewater, and all those contaminants in wastewater should be removed, and each aspect can have various ways of removing or mechanisms of removing. For example, if you have the turbidity, the suspended solids in wastewater, if you have the large debris and so on, those have their own mechanisms or ways of removing them. But when you have the dissolved solids in water, you have the microorganisms and so on, those also do have another ways of removing them. So if you see here the stages of treating wastewater, it undergo main 4 stages. We have the preliminary treatment stage, we have the primary treatment stage, and we have the secondary treatment stage. And the last one is known as the tertiary treatment stage. So at the preliminary treatment stage, which is the first line of wastewater treatment, here we expect to remove a large solids and the debris. And the methods that are applied here, they are simply screening. We do have the screening chambers, the grit removal, and the comminution that distract the large particles into smaller pieces before subsequent treatment. The second treatment stage is called the primary treatment. At this point, we expect that the suspended solids and particles that can easily settle, they are removed. So at this stage, we have several methods as well. We have the coagulation, flocculation, and sedimentation. And for coagulation and the flocculation, here is when you have the colloids, the particles that cannot settle easily, we add some chemicals like alum and the salts of aluminium and the salts of iron, so as to form what we call flocks. The flocks, once they have been formed, then they can be channeled to the next step within the primary treatment, which is sedimentation. And at this point is where we expect that those large particles can settle down and get removed. But the primary treatment stage, not all contaminants can be removed at this stage. Remember, we still have some of the microorganisms and the dissolved ions in water, and even some microorganisms, the heavy metals. So here we need now to move to have another compartment of the wastewater treatment, which is called the secondary treatment. At this stage, is where now the dissolved ions or biodegradable pollutants are also removed. Remember, in any wastewater, you can have various organic contaminants, and those organic, some of them, they can easily be biodegraded by microorganisms that can feed on them. But sometimes you can also have the non-biodegradable pollutants. So for the case of non-biodegradable pollutants, we will see that they will be easily removed at the tertiary treatment. But at the secondary treatment, here, there are several processes or methods that can be applied. One is called the activated sludge process, trickling filters, and anaerobic or aerobic lagoons. At this secondary treatment, we expect that there is a utilization of microorganisms to decompose those pollutants. And the last stage that ensure that water is safe for discharge or disposal or reuse is called tertiary treatment. Here is when now we applied the advanced method of water treatment, such as reverse osmosis, the advanced oxidation processes, disinfections, as well as filtration. And at this point, we expect that even pollutants or heavy metals with a very small size or that are present in parts per billions can also be effectively removed. So from this point, the wastewater can be safe for disposal or reuse. So the processes that I've explained can also be seen here, that we have the stage 1, the stage 2, stage 3, 4, 5, 6, and 7. Stage 1 is where the wastewater is pumped into the preliminary treatment, where we do have the screening process. And number 3, we do have the grit or sludge removal. We also do have the primary sedimentation. Is it visible? Yes. Hello. Is there a question?
Sorry about that. Just a second, I'll try to mute. Okay, please proceed.
Okay, so the stages that I have explained here, they can also be seen in this schematic diagram. So in short, the processes of treating wastewater follows this stage. You can see I tried even to show by using the colors. You can see the color is becoming faint, showing that there's a removal or there is a decrease in pollutants level as you move from the preliminary treatment toward the tertiary treatment. So by preliminary treatment, I think I have explained this one, but now for you to realize what is happening, you can see that there is influent. The water, the wastewater first passes through the screen and it goes to the grit chamber. Now, some of the design of the wastewater treatment plant does not show the coagulation and the flocculation stage, but this is one of the most important aspects of water treatment, and the exact location of the coagulation and the flocculation should just come soon after the grit chamber. And in some aspect, you can find that both preliminary and the primary treatment are fused. So you can, you may not be surprised to find a wastewater treatment plant that does not separate the two stages, the preliminary and that of the primary treatment. Now, from the grit chamber and the coagulation and the flocculation, the particles should be left to settle at the sedimentation tank before it can move to the next stage, which is now the secondary treatment. Now, at this stage, I said we are utilizing microorganisms that decompose some of the organic matter and other pollutants. Now, I mean, in terms of the efficiency, we can see that both sometimes the use of anaerobic treatment or aerobic treatment also relies on the nature or the composition of the wastewater. If the wastewater is highly composed by the organic matter above 500 milligram per liter, then it is recommended that you go for anaerobic treatment. But if the water is composed of the organic matter of less than 500 milligram per liter, you can just go straight for aerobic treatment. Sometimes both methods, aerobic and anaerobic treatment, can be used together. So in short, for the utilization of the microorganisms, one, we can apply. For the case of aerobic treatment, this one requires the supply of oxygen. So the oxygen will help the microorganisms to decompose the organic pollutants that are present in your wastewater. But for the case of anaerobic treatment, this one, the decomposition takes place in the absence of oxygen supply. You can see that for aerobic treatment and anaerobic treatment, there are also different techniques that are applied. For aerobic treatment, we can use the activated sludge process. The activated sludge, it implies just the mass of various microorganisms. But here you can also use the trickling filters, the moving bed biofilm reactor, as well as the membrane bioreactor. In short, all these methods requires the application of microorganisms. But you can also have the anaerobic, whereby the setup is that we have the two ways. One, you can opt for upflow anaerobic sludge blanket, and second is anaerobic digester. So here you can see the way the aeration process is enhanced. The aeration process ensure that there is a supply of oxygen in your wastewater that may also help for the decomposition, may support the microorganisms to decompose the organic matter that is present in your water sample. In short, the mechanism here is that the microorganisms is decomposed into, or is broken down into, carbon dioxide and the water. And you know that the carbon dioxide will just easily evaporate to the atmosphere, and it reduces the amount of carbon that is present in your wastewater sample. But when it comes to the anaerobic digestion, here is that it uses the microorganisms that does not require the supply of oxygen for them to survive. But for the case of anaerobic digestion, this one is mainly very important when maybe you want to recover some biogas, because through the anaerobic digestion, there is because there is no supply of oxygen, we don't expect that there is we will form the carbon dioxide. Rather than, we can end up forming the methane, which is the one of the important biogas for energy supply. So the anaerobic digestion has that advantage that we can also be able to harvest the gas through the anaerobic process. So these are the advantages that for the case of anaerobic, we can be able to recover some gases, methane gas, through the decomposition process. But also this one, it produces less amount of sludge as compared to the aerobic process. So for the tertiary, which is also crucial and very important, especially if you want to reuse such a wastewater for other uses. This one ensures that all pollutants that could have remained in our previous stages, they are also get removed from the wastewater. There are so many methods that are considered as a advanced treatment. One of the methods you can see here, we can use the filtration, because we know that there is a possibility that some of the particles could have remained when, from the previous stages of primary treatment and in a secondary treatment, but through filtration, those particles can get trapped in a filter media, and it allows the outlet to be somehow free from those pollutants. But here we can also apply, here is where we can also do the disinfection. We know that disinfection is just ensure that all the microorganisms that could be present in your wastewater sample are also removed. By disinfection, we normally do the chlorination, and in some cases, we can just use the ultraviolet. But in rare cases, the efficient ways of disinfecting wastewater is through chlorination. But sometimes you can use what we call advanced oxidation processes. The advanced oxidation processes, this one supplies is just one of the chemical ways of removing or of ensuring that even those organic compounds that are non-biodegradable, that there are some organic pollutants that can be hardly broken down by the microorganisms. So in a secondary treatment, those kind of organic pollutants will just remain in your water sample. But through application of the advanced oxidation processes that uses some chemicals such as peroxide or even ozone in the presence of ultraviolet and whatever, those chemicals normally they can be broken to form what we call the radicals, like hydroxide radicals. Those radicals can easily decompose some of the non-biodegradable organic pollutants that could have remained from the secondary treatment stage. But at this stage, tertiary stage, you can also apply the membrane filtration. The membrane filtration, this one uses various membranes, and this is the most important once, or if you want to use your water or to reuse your water, because it ensures that all pollutants, regardless of the size, they are also removed from the wastewater. But the filters also differs in terms of their pore size. You can see we have the microfiltration, you can have the ultrafiltration, there is also nanofiltration, and the one that has the smallest size and it cannot allow any penetration of any kind of particles is called the reverse osmosis. So you can see when the water passes, the raw water passes at the microfiltration, there is a kind of chemicals like the chemical that can be removed here are divalent ions, because for them, they do have somehow a larger size. But in a subsequent flow of water, there is a removal of the particles depending on their sizes. You can see the reverse osmosis can even remove the monovalencies and even heavy metals, because this one have a tendency of repelling the ion. So it cannot allow any passage of any kind of particles, including some of the microorganisms. But we also do have a constructed wetland. This is a natural, one of the natural ways of treating the wastewater. During the wetland, we allow the passage of wastewater capacity of absorbing or of using the nutrients like phosphorus or nitrogen. And by doing so, they also tend to eliminate those kind of ions from your wastewater. Now, the decision of what kind of maybe the tertiary method that you can apply will also highly depend on the source of the wastewater. If you think that your wastewater is from maybe the mining activities and you suspect that it could have been contaminated by heavy metals, of course, you must know this because before you go for the wastewater treatment or decision, the wastewater should be analyzed so as to know what kind of the particles or the composition that are in your wastewater. So through these stages, from the preliminary treatment stage to the tertiary treatment, we expect that water can be safe for reuse or for discharge. And one of the sustainable ways and eco-friendly practices in wastewater treatment is that wastewater treatment itself. Here you can see the sustainable and eco-friendly practices. What do we mean here? We mean that we want to ensure that there is a minimum environmental pollution, but we also minimize the water demand in the industries, but we can also be able to recover some valuable resources in the wastewater. That is what a circular economy means in this context of the wastewater treatment. So here, let us look on the sustainable and eco-friendly practices. Suppose you have generated the wastewater from the industry, and this wastewater, as we have seen, it should be directed. It should pass through the treatment process, various treatment processes as we have seen. Through this treatment process, this can also be integrated by other means of ensuring that you also recover some valuable resources like a biogas or even manure, or you may treat that water to the point that it may be used for irrigation. So you can see here, you can recover the nutrients, you can even have the clean water for reuse. You can also have the clean energy by harvesting the biogas like methane, but also you can have other valuable byproducts. So that is what we mean by the circular economy. And the importance of having the sustainable and eco-friendly practices in the wastewater treatment context within the industry is that it ensures that there is a reduction of water consumption, and it supports the sustainable agricultural practices by supplying safe water for irrigation, and also it recovers some resources like biogas and even nutrients, and it also ensure that the environment remain safe, because if you decide to discharge the wastewater, you discharge it at a minimum pollutant to the point that it may not affect the environment or the ecosystem. But if if you decide that the wastewater is, can be discharged, there are several ways, or there are several approaches that the wastewater is discharged. The first way and the common way that here in Tanzania is common is through a direct discharge of the wastewater, and mainly this one is directed in various water bodies, and we know that those water bodies like lakes or river, sometimes, or all case in all cases, they are some of the aquatic organisms that are living in such a water body. So to protect those organisms, we need a safe discharge of the wastewater. That's why all industry are supposed to have the treatment system. But if there is a proper treatment of that wastewater, it may be used for irrigation, and by doing so, it minimizes water demand. So, but if the industry fail to comply with regulations, there are some consequences for it. For example, in our country, we impose there is financial penalties if maybe you have been found to discharge the untreated wastewater to the environment, or the discharge permits, because we know there is before maybe you discharge any sort of wastewater, you must have a permit. So if you fail to comply, then that permit may also be revoked. But there are several legal proceedings that one who failed to adhere to the requirements of the wastewater discharge can also face. But we do also have the operational restrictions that if maybe you fail also to meet the requirements for the safe discharge or use of the wastewater that your industry is producing, then the operations can also be stopped. So those are some of the consequences that one may face if it happened that you fail to comply. But sometimes you also need to weigh the benefit of conducting the wastewater treatment in your industry. For example, here you have to use what we call the cost-benefit analysis. You have to weigh the cost that you will incur for operating such a wastewater treatment, and the initial cost, like for installations and so on, and the benefit that you're expecting to get by applying the wastewater or the reuse system, the wastewater reuse or recycling in your industry. But before, maybe I forgot to clearly indicate the sustainable and eco-friendly here. Here we are using what the common slogan here is that you have to adhere to the four R's. The 4 R's. The 4 R's. What are those 4 R's? The first one is the reuse. There is recycling. You recycle, you regenerate, and the last one is the recharge. So in short, for any sustainable and eco-friendly practices that also include the minimal usage of chemicals within the industries, and they should follow the 4 R's slogan, that you ensure that there is a reuse, there is recycle, there is a recharge of the wastewater, and all those, they address the environmental concern, they conserve water resources, and promote public health. You minimize the water demand, and you also minimize the environmental pollution while you maximize the reuse and you maximize the valuable byproduct that can be obtained from the wastewater. So the cost benefit analysis, we have seen that you should weigh the cost and the benefit of having treating the wastewater. One, for the case of cost, the cost may come from the capital expenditures and operating costs. While for benefit, you will analyze the direct economic benefit, like maybe by minimizing the water demand, by getting or by harvesting the energy, like the biogas, by recovering the resources like nutrients and so on. Those are some of the benefit of having the recycling or the treatment system. But for the environment benefit, because we know that once you have treated your wastewater, and by discharging treated wastewater, even the environment will be safe. So there are several steps in conducting the cost-benefit analysis. The first one is to define the framework for the analysis. Here, you should understand the aim, the objective, the kind of wastewater that your industry is producing, and you should also be able to determine what treatment process should I use, the kind of technologies that I need. The second one is to identify and classify costs and benefit. You should be able to analyze and to evaluate all angles by which the cost of having that treatment facilities in your industries, as well as the all possible benefits that you are expecting getting from such a system. But also, the third step is by drawing a timeline for expected cost and the revenue. You should be able to conduct or to calculate maybe after how long will I be able to have benefited from having this system, the treatment system, the recovery system, the recycle system in your industry, but also to monetize cost and the benefit, to optimize the cost and the benefit. And the fifth step is to discount cost and the benefit so as to obtain the present values, which is calculated from the net present values. I think we had time to look at this formula in a previous module, whereby you should get the sum of the benefits as well as the sum of the cost. You divide them with 1 plus the discount rate raised to the time period. So, and by doing so, you'll be able to understand the expected value of having the cost benefit even after a certain long period of managing that treatment system in your industry. But sometimes there are some emergencies that may arise in the industry that are directly related to the wastewater treatment systems in the industry. These are some emergency responses. You should have the response plan, which is vital for managing potential incidents related to wastewater treatment systems, such as spills, overflows, or equipment failures. But this one, the plan, it can follow these stages or steps. The first one is that you should assess the risk that might happen, and that risk should be associated by running the wastewater treatment system. The second one, you should also develop a response protocols that if there is a risk A, there is overflows, there is a spill, there is equipment failures, then what are supposed to be the responses toward such a risk. But also we do have the training and drills that are here. We need that all workers or all people that are working in that particular industry should also be trained on a specific risk that the industry could encounter. So they should also be aware, and they should adhere to some responses. They should be aware of the responses that they are supposed to take once there is a certain risk. But the public communication plans, because if you have already understand that maybe by running this kind of the treatment, like I'm expecting that I will be discharging wastewater toward the environment and whatever, you should have a plan to also inform the community living surrounding the industry. But here the number 4 and the number 5 are similar, because here you should also be in a position to collaborate with local authorities, because they will also be in a good position to understand what to, what they're supposed to do in case of emergency in your industries. So for the managing of the emergencies, this one have several aspects. The first one is the SECO, the emergency response management SECO. One is just like the way I've explained. It focuses on mitigation, preparedness, the response, as well as the recovery or the measures that you should take. So in short, in this module, from the point of collecting the wastewater to the treatment itself, to the discharge or to the reuse, to the cost benefit and the sustainable and the eco-friendly practices, is I have tried to explain. All industries, it is mandatory that because regardless of the kind of the processes that are taking place in the industry, we expect there is no any industry that can operate without supply or without use of water. And we expect that in one way or another, such industry may may produce water that is not safe for discharge. So it is recommended that all industries, regardless of the processes that they are or activities that they are conducting, is better that they have the waste water treatment system. So by saying so, that mark the end of this presentation, and I say asanteni sana. Thank you.
Wow, Dr. Magari, thank you so much for taking us through that presentation and module 4. It's our last module, but it is not the last we see of each other. So just to react on Dr. Magori's presentation, I welcome comments, questions, suggestions. Maybe I can just start with the chat box where Benjamin made a comment. Benjamin, do you want to go first?
Thank you, Doctor, for the good presentation and the training. It was actually insightful. I just have one question, or it's a bit of a discussion. Is biogas beneficial to be termed it as a eco-friendly solution, according to your experience?
Yes,
Am
Dr.
I
Magori.
audible?
Yes, I heard you.
Okay, can you hear me? Okay, now I think it is
Yes.
clear. Yeah, for the case of the harvesting the biogas from the system, I can say it just depends on the amount of the methane that you are expecting to harvest from the system. For the small use of energy, then it is beneficial. But again, you know, by harvesting the biogas, it means that you are also fighting the what we call the climate change impacts, because some of the contributors of the climate change are those gases, including the methane and some carbon dioxide and some other gases. So by harvesting the gases like the methane, it prevents the climate by ensuring that they are not going to the to the surroundings. So that could be another ways of advantages of harvesting this kind of gases from the wastewater. So I think, and that is very important, that in our systems, we have to ensure that we are not contributing to even a single emission of the gases that also may contribute to the climate change and associated impacts.
Okay, thank you.
Yeah.
And are we looking at only on what it impacts the environment, or are we looking also on the terms of costing and everything?
Yeah, as I said there, because there you should look on the benefits of having this system. One of the benefits is that you recycle, you minimize the demand of, okay, and the second is for environmental protection. That you are treating the water, you minimize the pollutants, but also you can generate, you can harvest the gases, you can get the nutrients, you can also use the treated water for irrigations and so on. So you should look at those various angles.
Okay.
Yeah.
And another thing you mentioned about there was a change of policy. Can you just please repeat on that part? I think it was on the first slide.
Yeah, of course, the national water policy that guide the water use, utilization, the supply, the wastewater, and all issues that are related to water. The policy was the policy that we were using was that of 2002. But there are some changes that have been made, and these changes they are now going to focus on some factors that have been found to affect the management of water within the country. So the changes, I think we are aware that this one was now we are no longer using data of 2002, and the President of Tanzania, I think it was last Friday, he inaugurated the new policy, not new, but there are some aspects from that of 2002 have been amended in this, the policy of 2025.
Okay.
Yeah.
Thank you very much on that.
Oh, okay, thank you. And I have that policy of 2025. If maybe anyone may need it, I can just
Yes, please.
share. I think, Mwamini, I will share with you. So for anyone who may need it, can have access to the amended the national water policy.
Yes, thank you for that. I'm
Okay,
looking forward
thank you.
to have a reading on it.
Okay, thank you.
Thank you so much, Benjamin, for that. So maybe we start with Ali. Ali Mjawiri. Okay, in case you're speaking, you're on mute. Okay, Ali does not have any comment. So we move on to Concedo.
Yes, good afternoon.
Good afternoon.
Thanks for the presentation from Doctor. All in all, I don't have any new comment. Thank you.
Okay, thank you, Concedo. Damas.
Yes, Mwamini, how are you?
Fine, thanks. How are you?
Yeah, thanks for the presentation. It was well covered. Yeah, I don't have any question.
Great. Okay, up next is Dinus. Dinus. Okay, Dinus has no comment. Elizabeth. Just in case you're speaking, you're on mute. No? Okay, Flora. Flora, no comment from you as well? Okay, Mr. Mrema.
Yes, Mwamini, thank you very much. And Dr. Magori, thank you very much indeed. I think, Dr. Magori, you need to get a gold medal. It's a fantastic presentation. And the highlights here is really, we have new policies. He rightly pointed out the water policy 2025, and I think is a good thing that we request to access to it. And thank you very much for your offer, if you can circulate it. And also from the Ministry of Water, you have also other manuals, water manual, I think pumping for those who are sizing pumps and so on. And we should try to make use of them. Now, my question is, you mentioned about the CBA, the cost benefit analysis, and you mentioned about NPV, the net present value. And my question is, you mentioned the value there, how you calculate it, and my question is now, what rate of value which you think? I think it should be less than 1 or more than 1, I don't know. In your opinion, which value do you think it is valuable for us to consider positive, worth, or that one which makes sense? Thank you very much.
Hello. Yeah, I think first thank you for the compliment. In that cost benefit analysis, I think the parameter that you're talking about is the discount rate, isn't it? We know that first of all, the essence of having that discount rate when you are calculating the cost-benefit analysis is that the value of money today is not the same as the value of money maybe in 5 years to come. So we should have a rate that ensure that to foresee if the benefit of having such a process in your industry will be the same maybe after in 5 years, 10 years, 15 years. So there's where we go for the discount rate, and this discount rate depends on various factors. It is just it given in percentage. It depends on various factors. For example, for the industries that have a small risk industries have a very small, needs a small discount rate less than 5. So it can be 0.5. But for a high risk industries, you can go even up to 10% or 15%. So the discount rate, this one will depend on the risk that can be associated by the process within the industry. And this one is given by, in percentage, by taking into consideration that the benefit or the value of that project you're having may depreciate as the time goes. So for the normal, the industry with a small risk or low risk, it is recommended that you integrate it with the discount rate of less than 10%. For the high risk industries, and so you may go even up to 15 or 20%. There is a rank of those discount rate. That's all I can say about the discount rate, but it just consider the value or the benefit of having that process by taking into consideration that the value will not be the same or may change as time goes by. Thank you.
Much, Dr. Magori, for that response. Is Mema, are you okay with the response, or do you have a follow-up question?
No, Mohamed, it's all right. Thank you very much, Dr. Magori.
Okay, thank you so much. Up next is Jasmine Musa.
Good afternoon.
Afternoon.
Asking on behalf of Leila, she asking about what are the public health and ecological consequences of wastewater treatment.
Okay. Dr. Magori, did you catch the question, or should Jasmine repeat? I think it's public health consequence of wastewater treatment. Is that correct?
Yes.
Okay.
Hello. Is okay. Is it the public health and ecological consequences of not treating wastewater, or can she repeat?
Okay, I can repeat.
Yeah.
Okay, what are the public health and ecological consequences of inadequate wastewater treatment?
Okay. Thank you. This one, I think we need to start from the composition of the wastewater. For the public consequences, because we know that water may be contaminated by those microorganisms and whatever, and we know that the viruses, the parasites, and some many microorganisms that are pathogens. So if one is contaminated by, is exposed to such microorganisms, that they may also be affected from various diseases, okay, like typhoid, diarrhea, dysentery, and many other. On the outbreak of infectious diseases, but if maybe the wastewater is also contaminated by some chemicals like toxic, harmful chemicals, heavy metals, and some industrial pollutants like pharmaceuticals, the microplastics, and so on, all those we know that they can lead to some chronic effects or diseases like cancers. They may get poisoned. Those are some, I can say, the health implications of not having inadequate treatment. But for the ecological consequences, I think this one you should look at when the wastewater that is highly contaminated by the nutrients, and if it discharged into the water bodies and whatever, they may cause the eutrophication. But also this one may make the aquatic organisms unsafe. And if the water is also highly contaminated by the organic matter, the organic content, we know that once the organic content contaminate your water, they may lead to the depletion of the dissolved oxygen. So when the dissolved oxygen decreases in the water bodies, we know that the city may not support the aquatic life, but also this may lead to the loss of biodiversity. So in short, there is a series of consequences of not treating the wastewater adequately. Just leave aside those benefits that I've mentioned, like recovery of the resources and whatever, but even there is a great chance of that biodiversity may become lost due to the damage to aquatic ecosystem. So in short, even the climate change, what I was talking about, the greenhouse gases, and we know in recent years, there is a lot of funds that have been injected so as to support all projects that are focusing on fighting the climate change. So by having or by not treating the wastewater adequately, it means that from the composition of those organic or nutrients, they may also emit the gases that are the greenhouse, of course, we call them the greenhouse gases, that may also affect the climate. So it has so many consequences of not treating the wastewater adequately. Yeah, thank you.
Okay, thank you, Dr. Magori.
Thank you so much, Dr. Magori and Jasmine. Up next is Maduhu. Maduhu, I'm not sure if you have any comments, suggestions. Hi, Maduhu, you're unmuted, but we can't hear you. Okay. Still, we can't hear you. Maybe you can try to unplug the headsets. Okay, no? Okay, well, you're fixing that technical challenge. Let me go to Sophia. Sophia? Sophia, do you have any input?
Just avoid.
William?
Hi, everyone. Thanks, Dr.
Hi.
Magori, for the wonderful presentation. My comment is on the waste that is generated by the wastewater treatment process, particularly secondary treatment. We talked about sludge in both anaerobic and aerobic systems. Dr. Magori, can you talk a little bit about the biosolids and sludge in general? Typically what is done with it, and what if we are to harvest or to get any benefit out of it, what would that be? Thank you.
Okay. I think the core of your, I can say that is not a question, but it's just a matter of clarifying that what is happening maybe to the sludge that are produced during the, in that third stage of wastewater treatment, because we know that the biggest part of the wastewater treatment is taking place at this stage, and here is where we expect it to produce a very large amount of sludge. So the management of this kind of sludge, because we know that in some cases they can just be disposed to the environment, but the management, a good way of managing this kind of solids or sludge, there are several ways. The first one is to conduct what we call the watering. And at this stage is just, it ensures that we reduce the volume by dewatering the sludge for them to be easy to, for easy handling and the transport, and even for disposal of this sludge. But also they can be stabilized. The biosolids that are produced at this stage, they can be stabilized so as to minimize the pathogens, odors, and the risk. And just a matter of understanding is that at this stage is where we expect to reduce or to minimize high amount of the organic matter, the nutrients that are present here in the wastewater sample. And we know that the odors, that is coming from the wastewater is mainly due to this kind of pollutants. So by stabilizing them, by stabilizing this kind of sludge, we can minimize the risk of this kind of odors. And there are several ways of stabilizing. There are several ways of stabilizing the sludge. One is through aerobic stabilization or anaerobic stabilization, or even lime stabilization. localization. But another ways of managing the sludge is through incineration, that the biosolid can be incinerated at a higher temperature so as to decompose them. But this environmentally is not recommended because it uses high amount of power to provide high temperature requires for them to be incinerated. But sometimes after you have stabilizing or dewater them in a dewatering, we can do a landfill, or they can be applied as a fertilizers, because we know that since they contain some of the nutrients and so on, they can be useful for the application as a fertilizer. But sometimes in recent years, this sludge, they can be used for, like I can say, for making the briquette. The briquette, some I can say through the watering or removing or drying this sludge, they can also be essential to be used as a source of energy for cooking and so on. But also, this sludge can be used in construction to make bricks and so on. So in short, there is several ways of managing those sludge. As I said, the biosolids that are produced, and benefit of them, like you can recover some resources as well because they contain high organic content, the nutrients and so on. So there is a chance of recovering some valuable resources. And also we can recycle the nutrients from them. And by doing so, we can minimize what I have been talking about, the climate change mitigation. So that's all I can say about the sludge management that are produced at the secondary treatment stage of the wastewater treatment. Thank you.
Thank you so much, Dr. Magori. William heard the magic word, which is vitalizing energy, I think, in your comment. So, yes, I hope that is satisfactory, William, unless you have a follow-up comment. William? No? Okay. Maybe I go back to, I think Maduhu. Yes, is your mic working? I will take one last comment from you before we close the class. Yeah, personally, I can't hear you. Okay, that's fine. The good news is that we'll be meeting in almost 2 weeks or less than 2 weeks, from the 8th to the 10th at 4 Points by Sheraton for the in-person training, where we'll have Dr. Maguri and Dr. Clarence with us. They'll take us through the modules and some exciting site visits. So I hope you have your calendars blocked for the sessions. Regarding the ATINGI, once you sign up on ATINGI, just send me an email so that I can register you for the course, because it's currently locked, and I'll have to enroll you so that you can be able to access the course. But other than that, Dr. Magori, you're fantastic. Thank you so much for taking us through the past 2 modules, and everyone who managed to stay for the past hour and a half. Thank you so much. I'll hand over to my colleague Pendo to say some closing remarks. Pendo. Pendo, you're on mute. No? Okay. Pendo is not ready to say anything. So Dr. Magori?
Yeah, okay, Mwamini. I can say just thank you. And most of the questions or comments that have been raised, they were so good, and because we had only like 40 minutes to have this kind of presentation, and there is so many issues that we are supposed to be covered, but through those questions, I think we have tried to somehow make the trainees to understand. But I can say thank you, and I'm looking forward to meet you during the in-person training. Thank you.
Pendo, I think, is back. Pendo, do you want to say some closing words to everyone who managed to stay with us for the past hour and a half before we close?
Hello, everyone. Hope you can see me. Yeah. Okay. Thank you so much, Dr. Magori. Thank you, everyone, for attending this session. It was quite insightful. And yeah, me not being a water expert, I am learning a lot from the session. And I hope by end of this, I'll be able to, to also get a certificate as a participant as well, because I've been following up. And yeah, thank you, everyone. And as Mamini has mentioned, we look forward to seeing you in person soon. I think she maybe has already said it, or maybe would also highlight it as she closes. But yeah, we look forward to meeting you in person and engage more. Thank you so much, everyone.
Okay, everyone, thank you. That's it for today. Look forward to my email regarding ATINGI and the webinar recordings. But other than that, see you on the 8th. Cheers.
Cheers.
Bye.
Bye-bye.
Bye-bye.
Bye. Have a good evening.